So there are these things called negative exponents, and they're not called negative exponents just because they have a bad attitude. There's other good reasons. The rule kind of goes something like this. If I have a raised to the negative m, that is the same as 1 over a to the positive m. And we use this rule to help us to simplify polynomial or monomial expressions, and I'll leave it at that. We'll use this to simplify. And there's another variation of the rule that looks like this. If I have this, that is the same as this. And then there's another one with fractions, but I want to stick with this for right now. So, where did this come from? How do we know that this really works? Well, let's take a look at a couple of examples. If we tried something like, let's imagine that we had 2 raised to the power of 3. Hopefully you know what that is. That should be 8. And if we have 2 raised to the power of 2, that should be 4. And 2 raised to the power of 1, that should be 2. Hopefully I'm not telling you anything you don't already know. But here's the part that gets kind of interesting. Could we make a prediction about what 2 to the 0 power would be? Aside from memorizing some rule, maybe you know it, look at the progression here. If we go from 8 to 4, we get there by dividing by 2. If we go from 4 to 2, we get there by dividing by 2. And so maybe we could imagine that to get to the next possible number, we divide by 2. And I want to mention that 2 is our base, and maybe that's related. So anyways, let's take a look. So if we did divide 2 by 2, we would get 1. Now, for those of you that know the rule, there is this rule that says raise a number to 0 power and you get 1. And in this case, it sure looks like it worked out. Let's go a little bit further. What if we have 2 to the negative 1 and maybe 2 to the negative 2 power? So what can we expect to happen here? I would say that probably we're going to divide by 2 again, and then after that maybe we'll divide by 2 again. And let's take a look and see what the results are if we do those things. So if we take 1 divided by 2, we get 1 over 2. And if we take 1 over 2 and divide it by 2, that's a little trickier. But just remember, 1 over 2 divided by 2 is the same as 1 over 2 times 1/2. And so we would expect to get 1/4. So 1/4 goes here. I'm going to go ahead and get rid of this, if you don't mind. Okay, maybe not. Okay, let's say goodbye to you. Okay. Now, something I want to point out is that really 1 over 2 could be rewritten as 1 over 2 to the 1, and 1 over 4 could be rewritten as 1 over 2 squared. And if that was the case, maybe you could begin to believe that this is equal to 2 to the negative 1 power, and this is equal to 2 to the negative 2 power. And you can begin to see where this rule comes from. Now, some of you might say, well, okay, that's fine. It works with 2's, but what if we tried something else? And I think it'd be worthwhile to go through a quick exercise. 3 to the 3rd is 27. 3 to the 2nd is 9. 3 to the 1st is 3. And so 3 to the 0. Divide by 3, divide by 3, divide by 3. I'd expect 1 again. And 3 to the negative 1. Divide by 3, sure enough, 1 over 3 to the 1st power, and 3 to the negative 2, 1/3, times, again, dividing by 3 is like multiplying by 1/3, so 1/3 times 1/3 is 1/9, and again, that could be rewritten as 1 over 3 to the 2nd power. So, 3 to the negative 2 is the same as 1 over 3 to the 2. I just wanted to take a minute and make sure that you understood how this rule worked with negative exponents and where it came from. Now we need to make use of it. I'm going to show you a couple of quick examples. I'm not going to walk all the way through the complete simplification. I just want to do part of the some of the steps so you can see how negative exponents work. See this y to the negative 2? It's the only negative exponent in this entire monomial. And so what I'm going to do is this. I'm just going to rewrite this as x to the third, z to the fifth, over x squared, y to the 7th, because that just stays down below, and then y to the 2nd, z to the 9th. I'm not going to simplify the whole thing. I just wanted to point out if I have a y to the negative 2 in the top of a fraction, I simply move the y to the bottom and make it a positive 2. We're going to leave this example right there. There's a lot more simplifying that could be done. I just want to show you a couple of basic concepts. Alright, let's try another one. In this case, maybe I'll tack a little bit more on here just so that it looks like there's a few more things going on. Okay, there we go. See how the c to the negative 5 is in the middle of all this? I'm just going to rewrite it with a positive exponent for the c, and the way I do that is I move the c to the top, and then I leave everything else in place. So I'm not trying to say that these examples are examples of rocket science. I just wanted you to get an idea of how you can move things around. Let's go ahead and try another one. Here's one that I always find to be interesting. This is one where students inevitably make mistakes, and I'm not sure where they get the idea from. A lot of times students will try to take this a to the negative 2 down to the bottom, and for some reason they take the 3 with it, and I'm not sure why. So I'm going to show you the correct way to do this. It should be 3b to the 4th all over. We'll have 2 b times, I should have put the a first, but that's okay, a to the negative 2 c cubed. I can always rearrange it in the next step if I'd like. That is the beauty of the commutative property of multiplication. You can write these things in any order. It's just usually we prefer to have, let's get this right. This is plus 2. And this is plus 2, there we go, and then c to the third power. Okay, so notice all that happened here was I had 3 times a to the negative 2. The 3 and the b to the 4 stay on top. The a to the negative 2 goes to the bottom, and a goes to the positive 2 power. This one's kind of interesting. It might have an ending that you did not expect. Again, I'm not going to go all the way to simplification, but basically what you have is this. 3 times a times b all over a squared times b cubed raised to the power of 2. Now there's a lot more that can be done to simplify, but I just wanted to show you a few examples where we have negative exponents, and they're embedded along with some other stuff, and here's how you deal with them. When you have a variable raised to a negative power, you can move that one variable. If it's on top, you'll move it to the bottom. If it's on bottom, you'll move it to the top. But you don't take the other variables with, unless they're in parentheses, like here. In this case, everything in parentheses has a negative exponent, so it all moves to the bottom, and then we get the positive exponent. All right, I think that's pretty good. Let me see, maybe one more. Oh yes, I'm definitely glad I remembered this one. For this one, for some reason, people have a hard time writing these out in multiple steps. Please, don't let that be you. Take multiple steps. Let's do one thing at a time. We've got negatives inside the parentheses, and we've got negative exponent outside the parentheses. So here we go. What I'm going to do is I'm going to just rewrite the stuff inside. So I'm going to make this x, and I'm going to take this x to the negative 3, move it to the top. And then I'm going to take this y to the negative 2, move it to the bottom. and then I'm going to write the negative 2 exponent on the outside. So I'm just dealing with the negative exponents on the inside. Now I'll deal with the negative exponent on the outside. There we go. Now, there's still more that could be done to simplify this, but what I wanted to point out is that it's really important that we do this in two separate steps. This x to the negative 3 moves to the top inside. This y to the negative 2 moves to the bottom inside. Only after all of those things have been done do we deal with this negative exponent that allows us to flip the bottom to the top and the top to the bottom, and then make that exponent positive. Okay, one last one. Sorry, I could just not resist. Here's one that's common, is people look at maybe something like this, x, y squared over, who knows, x cubed, y, and what happens is people start to forget what they knew before when they start learning this new material. So as soon as we learned that a negative exponent can move a power from the top of a fraction down to the bottom of a fraction, all of a sudden we start thinking that the thing that we had before for years, we start thinking that we can do new things with it. So what people want to do is they want to take this negative 3 and move it to the bottom of the fraction. You can't do that. You never could do that before, and you can't do that now. The other thing that happens is sometimes people think if this x was raised to like a negative exponent, that for some reason maybe this negative exponent cancels that negative exponent. And again, they do not. This simply could be rewritten this way. Negative 3 y squared all over x cubed, x to the 4th y. We just take this x raised to the negative 4, move it down to the bottom, make it positive 4 exponent. The negative 3 stays in place, and the two signs do not cancel. All right, that's all I got for you.